Hello everybody. So today we are starting our new unit. It is Unit 4, our Quadratic Relations Part 2. And Day 1 is Vertex Form of the Quadratic, which most of you should be used to from your grade 10 material. Here are your homework pages that you are responsible for, right here at the top. And you can find the textbook under Resources Content if you need to. So, just as a warm-up, kind of to go back to the last thing that we were doing when we were together, is graphing a quadratic versus four transformations. So again, here we have a quadratic in vertex form. In vertex form, there's an A, an H, and a K value here, and they each control specific transformations of how we're going to move and translate our parabola on the grid beside. So first of all, our A value is always right here at the front, and our A value here is -1. What that means is we have a vertical reflection over the x-axis. Okay. Our next value that's present in the equation would be right here, -3, and this is our H value or our X coordinate to our vertex. Remembering it is always the opposite sign as it appears in the equation, so our H value is actually 3 here. What that means is it's a horizontal translation. If this value is positive, then it's a horizontal translation right. If it's negative, then it would be left. So in this case, it's a horizontal translation 3 units right. And lastly, the final value that appears in our equation is here, and that's 5. Okay, that is our K value, and that means it's a vertical translation up 5 units. If it was negative, it would be down. Every time we start with a quadratic and we're graphing these quadratics, okay, you're always going to start with our base graph, and at this point we should know what the base graph is. Our base graph is essentially y equals x squared. So you're going to start with that, and you're going to plug in these values for x and y. And this will be our base that you start with every time. So x values from -3 to +3. And if you were to solve for y here for each of these values, you just simply plug in that into your equation. -3 squared, well, that's 9. Here, -2 squared, that's 4, and so on. The rest of these values would follow some sort of pattern by doing the same thing, plugging that value of x into the equation and solving. So here's our base graph. And let's go ahead and actually graph that onto our grid right now. So the first point we need to graph is -3 and 9. So -3, 9 is right here. Then we have -2, 4. We have -1 and 1. We have 0, 0. 1 and 1, 2 and 4, and 3 and 9. So we have just graphed our base graph, okay? And connect that with a smooth curve. And if you're not using colors, then you can simply label that as such. Now the next one, in our next table of values, we're going to want to apply that A value of -1. In order to apply the A value up here, you're going to want to multiply y by a. So you're going to look at all the y values you had in your first table. So 9, 4, 1, 0, 1, 4, 9. And you're going to multiply all of those things by -1. Okay, so your x values stay the same. Nothing's changing. You've applied no transformation to that. And your y values, simply they're all just going to turn into negatives because you're multiplying them by -1. And that's our second graph that we're going to put on to our grid here. So now we have -3, -9, which would be right here. We have -2, -4, which would be right here. -1, -1, 0 and 0, which is shared, 1 and -1, and then we have 2 and -4, and we have 3 and -9, and here's our second graph. And again, if you're using colors, that's great. If not, you're going to want to label that with y equals -x squared, which means you've applied that transformation for that a value. The last one we're going to do here would be our horizontal and our vertical translations all in one. So in order to apply our h value, okay, we're going to add h to x, and in order to apply our k, we're going to add, sorry, I'll scroll that up there, we're going to add k to our y. So you're going to look at the previous table. My x value is -3. If I add 3, that gives me 0. -2 plus 3, 1. -1 plus 3, 2. And you can see this pattern actually occurring here, in which you would get all of these values. So if you keep going, -1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4, and so on. Now you're going to add 5 to all of our y values right here. So that would be -9 plus 5, which is -4. -4 plus 5, which is 1. -1 plus 5, which is 4. And this is also going to follow a pattern. And why is that true? Well, our parabolas are symmetrical, so you will see repeating values in your table. And the last thing you need to do here is graph all of these points. So going back up to our graph here, we have x equals 0 and y equals -4. X equals 0, y equals -4. Okay, we have x equals 1, y equals 1. That'd be right there. X equals 2, y equals 4. Okay, 3 and 5. 4 and 4. 5 and 1. And 6 and -4, which would be right there. And that would be your final graph right here. And you could write out the entire equation that was given to you in the equation to represent that. And there you have graphed a full transformation with all the information necessary. Okay, that is a bit of a review. But moving forward, we're going to take a look a little bit deeper into the vertex form of a quadratic. So there's some information here. Choose through to read it or listen. The general form for a vertex is as follow. We remember this notation here. F of x, or f at x, is something that we've been looking at quite a bit. So we should know that that is just another notation that we use to represent y. And then we have our a, our h, and our k values, which are important to us in determining certain properties about our quadratic. Now the a value in this equation, and any equation of a quadratic, standard or factored, determines the direction of opening. Okay, if a is positive, then the quadratic will open up, like so, as you see in this graph to the right. And if it is negative, then the quadratic will open down, like you would see right here. Okay, you can identify the vertex of any quadratic function by observing the equation in vertex form. That's why they call it vertex form. The vertex of a quadratic is always represented by the h and the k values. That is, h represents the x value of the quadratic, and k represents the y value. So if I gave you some sort of example here, and I'll just make an equation up. For example, y is equal to 4x minus 10 squared plus 2. Well, here's your h value right here. Sorry. Here is your k value, and those two values control your vertex. Remember, h is always opposite in the equation. So your x value of your vertex would actually be positive 10, and the y value would be 2. So this here would be the vertex that corresponds with that equation that I just made up. So you just simply have to look at it and write it out as a listed point. Moving forward, we have a couple of examples that will help us through that. So, example 1. What are the coordinates of the vertex for h of x is equal to 5x plus 8 squared plus 11? Well, the coordinates of the vertex then, what's important to us here is that h value and that k value. H is -8 because it was positive in the equation. K is 11, therefore our vertex is -8, 11. Okay, what does the sign of the A value tell us about this graph? Well, the A value here is that leading coefficient, which is 5. This is positive, and if it is positive, then our graph or parabola will open up. Okay, pretty straightforward. The next one, does this equation open up or down, and does it have a maximum or minimum point? Okay, now we're looking at a different terminology. We'll answer the first part of the question. So the A value here is -3. Therefore, if it's negative, it would be opening down. Just as a note, the vertex for this would be -5, 3. If I took the time and I graphed this, and I'll just draw you a rough sketch of where this would be. Well, -5, 3 as a vertex would be somewhere in your top left quadrant, because that's where x would be negative and y would be positive, and it opens down. So it might not look exactly like that, but it'd be a rough sketch. Now the second part of this question, it says, does it have a maximum or a minimum value? It's referring to the vertex of this point, so this right here, and it wants to know, well, is that the highest point, the max point, or the lowest point on our curve? And in fact, in this example, it is the maximum value. So it's important in questions like this that you identify your A value, your vertex, and then you can draw even a rough sketch as I have done here, and it will help you to actually visualize the problem, and therefore you can make a conclusion that therefore it's a maximum value. Just as a note here, if you want to write this down, it will be, if it opens up, if the quadratic opens up, the vertex is a minimum. If it opens down, the vertex is a maximum. Just as a note that you can make that. Moving forward. Example 3. Does this equation open up or down? Is it a maximum or minimum? And what form of the quadratic is it? So I'm going to actually end on the tail part of this question, which asks us, is it simply a, or what form is the quadratic? And we should know that a form like this would be what we call standard form. Okay, doesn't matter what equation you have, standard, vertex, or factored, they all have an A value, and that's always that leading coefficient in the equation. So in the previous one, it was the first value you see. Same thing here. It is that 5, that value, that coefficient right at the front. That is your A value here, and it's going to tell us your direction of opening. So it says, does it open up or down? Well, opens up. Why? Because A is positive. Okay, and then it just asks us, is it a minimum or a maximum point? Well, going back to the note I just put down, if the quadratic opens up, which this one does, then the vertex is a minimum. So therefore, this vertex is a minimum. Okay, And the next one, well, same thing. I'm going to start at the tail end of this question. It says, does this quadratic open up or down? Is it a maximum or a minimum? And what form of the quadratic is this? Well, this one is not something we've seen yet. So therefore, the only one we haven't looked at is factored form. Okay, and again, like standard and like vertex form, factored form has an a value, which is that leading coefficient right there. Okay, that leading coefficient, that's the -2. That's our a value. If it's negative, therefore, it opens down. Why? Because a is negative. Okay, and then again, is this a maximum or a minimum? Well, if our quadratic opens down, therefore, this vertex is a maximum. So there you can see the comparison between our first question, example 3a and 3b. So if we have it opening up, opens up, then it's a minimum. If it opens down, then it's a maximum. Okay? And our last problem for today's lesson is more of a thinking problem. So, a parabola has a vertex at -6, -5, and passes through the point -3, 4. Determine the equation of the parabola in standard form. So, just as a note, you can't always jump right into the form that the question is asking us. Here it is standard form. It gives you a vertex and a point. You cannot jump in and just plug these values into a standard form equation. My recommendation, if it gives the vertex, if you are given the vertex, then start with vertex form. Okay, so, well, the general form for a vertex is y equals a x minus h squared plus k. Now, if you're wondering where I got that from, just look back to the beginning of your note. It's written down right there and explains what each of those values mean. On the left here, I'm going to write down our steps. So, we're going to start with vertex form. Next, you're going to want to plug in or substitute in your vertex, remembering that your vertex is your h and your k value, and the other point which is x, y. Okay? And that's where you're going to plug that point in into your equation where x and y is. And the whole point of this is that we're going to use that information to kind of follow order of operations. We're going to isolate and then solve for our a variable because that's the only part of this equation that we're not given. So we want to figure out what that a variable is that I've just highlighted. Okay, so let's start with step 2. Well, I'm going to plug in that point. Well, y and x are right here as -3 and 4, so that's going to be 4. We don't know a. X is going to be -3. And then I'm going to want to plug in my vertex for h and k, which is right here, -6, -5. Remembering when you plug that h value into your equation, it's the opposite. So if it was -6 listed in the question, I'm going to plug it in as +6. And my k value still remains the same, which is -5. At this point, once you've plugged that information in, your step here would be to follow bed mass. I really hope we know what that term means by now. And isolate and solve for a. Okay, so now we need to follow order of operations. What does that mean? Brackets. Well, in the brackets, -3 plus 6 is positive 3. Okay. You're going to want to also apply that exponent, which gives you now 9a minus 5. You're going to want to bring all of your constants to one side and keep your variable 9a on that side. Once you do that, opposite operations tells us that this is now going to be 4 plus 5. Okay, 9 equals 9a. In order to identify what a is, opposite operations again. If it's 9a, we divide both sides by 9, and that leaves us with an a value of 1. So you have solved the problem. The only last thing you need to do is rewrite the equation with all of the variables. Well, since a is 1, in math we don't need to write our 1s. All you have to do is write x plus 6 squared minus 5, which means we've just plugged in our h and our k value for a vertex, and therefore that is the equation in vertex form. Now, if you want to go to standard form, you need to simply expand this problem. Well, what does it mean in this problem here to actually square this? Well, remembering what it means to square a number or a value, it means to multiply it by itself. So you're going to rewrite this. Y equals x plus 6 times x plus 6 here. And you're going to use binomial expansion or FOIL to expand this x plus 6 times x plus 6. Okay, well, if you're going to expand it means you need to multiply. Okay, well, x times x, that gives you x squared. X times 6, that gives you 6x. 6 times x, that gives you 6x again. And 6 times 6, that is 36. All you have to do is collect your like terms here. You have x squared plus 12x plus 36 minus 5. And collect your like terms again at the end, your two constants, and therefore your equation in standard form is x squared plus 12x plus 31. And therefore you've completed this problem. Okay, and therefore we have our summary here at the end. All I'm saying here is 1, the a value controls or defines the direction of opening. Okay, and if it opens up, then your vertex is a minimum. If it opens down, your vertex is a maximum. Alrighty, and that's everything for today's lesson. Pause, fast forward, rewind these things, go over it yourself if you need some extra work, and then take a look at those suggested exercises from the textbook. Alright, enjoy your day.